This is Unit 4, Topic 4, and it is testing a claim on a population proportion. So in the last two topics, we estimated a claim about a population mean by hand if we had the population standard deviation, and then we estimated a population mean where we did not have the population standard deviation. The major difference between these two was that we did the left column one by hand, and the right column one we did in Stata, which is pretty typical of where we want to go for our future. This one can be done in Stata as long as you have the newest version. If you bought at the beginning of the semester, you would have that. But we move on to the next page. I think that this is actually a much, much, much nicer test. However, we start with this one just because we're familiar with the normal distribution. So even though it is more complicated, it does kind of make sense to come first. But this is going to be kind of a relief because there's no data. We could have the data in Stata. I would never do it that way at all. I wouldn't really recommend doing it like that. But there, as always, there's two documents in the topic for material. I'm going to add the reference table just because every semester I get a lot of questions. I have the reference tables everywhere. You have to be able to find them, correct? So what you'll find is that we've already set up these HO and H1, the hypotheses. We've already tested these assumptions. We've already worked with the normal distribution. And there's only one Stata program that we're going to be selecting from. So I think this is a nice topic to end the week with. So the one thing that I will say is that these problems I chose slightly more interesting ones, which they do have a little bit more verbiage to them. So you need to make sure that you read clearly through everything. So the paper Debt, Literacy, Financial Experiences, and Over-Indebtedness in the Social Science Research Network Journal included the analysis of data from a national sample of 1,000 Americans. One question on the survey was, you owe $3,000 on your credit card. You pay the minimum payment of $30 each month. At the annual percentage rate of 12% or 1% per month, how many years would it take to eliminate your credit card debt if you made no additional charges? The respondents had the option to choose less than 5 years, between 5 and 10 years, between 10 and 15 years, and never, you will continue to be in debt. E, don't know, and F, prefer not to answer. So I usually pause and say, well, think about this before you look at the last answer, although it is, right here. But out of the 1,000, only 354 chose the correct answer of never. So basically, when you make a payment, part of it goes towards interest, and the other part goes towards what you owe. So you'll basically always be paying something. I would recommend looking up an amortization table if you have a mortgage. It's pretty eye-opening, especially with how at the beginning of your mortgage, most of your payment goes towards interest. And then there's kind of like, it's like a curvy line where eventually you start paying more towards principal of your loan than of interest. But so the question is the proportion of adults that answer this question correctly less than 40%? Use the 0.05 significance level. So the big change here is now proportion starts to become kind of our keyword. So as soon as I hear proportion, I would now leave this page finally of the statistical tables, and I would get to this page right here. So testing a claim on a population proportion. So setting this up is going to be very similar to the other problems. And that we start with steps 1 and 2, hypotheses, assumptions, picture, all that jazz. So instead of putting a mu here now, we're testing to see if the proportion is less than 40%. So our HO and our H1 are going to be equal to less than, because this doesn't have equality in any way at all. So we would just drop this down into our H1, and our HO would be this with an equal sign. The assumptions that we must check, again, are the same as they were for confidence intervals. Random is not specified, so you can't get check happy is what I call it. You actually have to X this, because this was probably a voluntary survey, I would guess. However, they do have 354 successes and 646 failures. So that does pass that assumption. So when we get down to our picture, proportions follow a z-distribution. So what this means is if I sampled 1,000 over and over and over and over and over again, the proportion of people that got this question correct would follow the normal distribution if I put them on a histogram. So the histogram would be this shape pretty closely. So when you go into Stata, the test that you want to select is going to be with the other tests, and it's going to say proportion test calculator. So we're never going to do a proportion test. It's possible for your project that you might use that, but I already have 354 out of 1,000. That's my summary statistics. What else would I need to know about it? So the test calculator has a sample size of 1,000, and so you have two choices here. If you check this box, instead of sample proportion, you can put in 354. So it's using this as a count instead of a sample proportion. If you don't check the box, you would put in 0.354. And the reason for that is it's asking you p-hat. And that is the number or the proportion of people that said, that got it correct, which would be 354 out of 1,000. Or 0.354. So I'm going to do, before I click OK, I'm going to type them in both ways, but after you hit OK, they're going to be the same. The only reason I don't like this method is that it requires you to round very often, and I prefer not to round until the end. So in that situation, I will choose to hit the box and actually have it calculate the proportion itself. So the hypothesized proportion is going to be 0.4, because that's what we're saying it is. We're saying it is 0.4. So that's always going to come from HO. And then we would need to set up our picture for our step 7. We are left-tailed, which leads the 0.05 to be over here. And so then we would have a second tail we'd need to build ourselves in order to make this symmetrical. So this would have a 90% confidence level. So once you've selected that, that's everything that you need to input into Stata. So you would hit OK. And so the z-score that you would get, negative 2.97, so that's way down here. Shade the left tail. And the size of that is from the p-value over here, because we have a less than in our H1. So 0.0015 isn't very big, so this should be pretty small in the scheme of your whole picture. The p-value is less than 0.0015, so we would reject HO. And if we're rejecting HO, then that means we're going to support our claim, because the claim is H1. So we're going to support the claim that the proportion of adult Americans that correctly answered the question is less than 0.4 or 40%. So they are answering the question correctly at a rate of less than 40%. So now the confidence interval for this data goes from 0.3291 to 0.3789. This does not have 0.4 inside, which supports the fact that we rejected HO. We said, hey, HO, you're not true. So 0.4 shouldn't be inside here, or else, we would have a problem. I'm going to try something really quick. it's still not inside. Okay, never mind. If you had accidentally had the wrong confidence level, it's possible that you could have ended up having 0.4 inside here, so you would conflict. But we don't. That's a good thing. So 0.4 is not inside. Our sample data does not suggest that 40% is viable. So the difference here is 40 minus the closest number, which would be 0.0211 or 2.11%. So I know that I'm going through these faster now, but my hope is that when you get the page and the blank, that you are able to, at the very least, set these problems up. So I'm going to go through number 2. I'm going to leave you completely on your own for number 3. This is a very popular problem. I think it's very interesting. The article Statistical Evidence of Discrimination from the Journal of American Statistical Association, they discussed the court case Swain v. Alabama in 1965, and they alleged that there was discrimination against blacks in the grand jury selection. And so this is really important when you're making a grand jury, that your jury is representative of the population. So it's the same concept of, it's a sample basically. So census data from that time suggested that 25% of those eligible for grand jury service were black, yet a random sample of 1,050 called to appear for possible duty yielded only 177 that were black. So the first thing is that I'm just dying to know what this percentage is. So I can't go any further. So 17%. I mean, it's pretty low compared to 25%. But the question is it statistically lower? Is it so low that we would conclude that it's statistically different based on the sample size, and the significance level will come into play as well. So test the claim that the sample argues in favor of discrimination, and that means that the proportion is different from 25%. So this is similar to our re-bowling kids because we want to test for a difference. So the claim is that the proportion is different from 0.25. And if this is the case, it's statistically different, either too high or too low, then they really should have reevaluated. But unfortunately, corruption is, I mean, sometimes impossible to prove, but it's probably pretty present in all times of politics. So if we have a not equal to for our H1, then we only have the option, which we only had anyway, of having just an equal sign for our HO. They did do a random selection that passes, and we do have 5 successes and 5 failures, so that passes as well. So I'm not going to forget this time. I'm going to set up my step 7 picture so I can complete my calculator in Stata. So we have a 0.05 significance level, and we are two-tailed. So that means we're willing to allow 5% in the tails, which there's 2 of them. So we're already symmetrical. We don't need to accommodate to do any symmetry at all. 95% would be our confidence level. So when you go to select the test, I'm way off here. This is a case where I would check the box. So I'll show you your choices. So hypothesize 0.25. Do we want 95%? Yeah. So your 2 choices are, is you can put this number in all of its glory. I've already messed up once. And it does let you keep on going, but I wouldn't do that. Realistically, you'd want to say, okay, I want to leave it up to technology to do the rounding. So when you check this box, it enables you to type in a count instead of a proportion here. So this isn't p hat, this is just the numerator of that calculation. So when you hit OK, you get a pretty far out z-score, and not far out as cool. In this case, far out as wow, they really messed up. So z equals negative 6.09. When you go down to the p-value here, you do not put 0. There's no such thing as a 0 p-value. Technically, nothing is impossible. Okay, it's just very, very, very unlikely. So it's really important that you put a 0 plus here. On your picture, I labeled both of these because this one was a little unique in that it was farther out there. So, and then I also put the shaded up here, and that 0 plus is not 0. There is some area that is there. I'm interested to see really quick if this gives us any decimal places. Yeah, so it's, and then we actually are doubling this because we have 2 tails. Let's double that originally. All right, so it's 0.0000000001. So I'm just trying to prove to you that it's not 0. It is some very small value, but it's not 0 because nothing is impossible. So you can't really prove that something can't happen. Actually, that you could disprove that pretty easily, but I have an analogy I'm working on. Maybe it'll come out. So the p-value is low, we're going to reject HO. And HO is, hey, there's no discrimination. However, we rejected it and we went with H1, which is supporting the claim that there was discrimination since the proportion was different than 25%. So now what I want to know is, how different from 25% is it? Because technically it still could be dumb luck, right? It could be a 0.000001% chance that dumb luck just happened to get this compilation of people. But the difference that it's off by, so our confidence interval is 0.1459 to 0.1912. So the minimum that they're off is 5.88%. And I mean, if you're thinking about out of 100%, I think that's a pretty big deal. It's not always going to be a perfect representation. However, deciding that it's statistically different, not only one, and it's statistically different by this much, definitely is favor of discrimination occurring in this case. So the last question, which I'm going to leave to you guys, is again real data. There's not very many cases where we're not going to have real data in the future because it's much more interesting. This problem, I don't think anything funky happens. So I'm going to leave that one up to you. As always, please feel free to email me if you have any questions. The learning quiz for this week has one of each type of problem. So if you find yourself doing the same type of problem twice, consider that you have one of them chosen wrong, and just shoot me an email if you want to try to fix that if you are unsure.